Now that I've had time to analyze all the new things I've learned about this generator slash alternator, I want to redo the sine wave representation once again. And here's a picture of a sine wave. You notice that slot 4 with the south face generates this sine wave on a little less than 180 degrees. And then the north face also at the same time generates this sine wave, which is narrower than the previous one. The average of these two comes out like this and doubles the amplitude. So this is 120 volts AC here at the top, RMS. And we have this little bit of dead time here, which is a half of 15, another half of 15, which is 15 degrees of dead time where there's nothing being generated. At this point then the faces reverse and they come down here, and the yellow now has 4 windings and the red has 3 windings. Up here the red had 4 windings and the yellow had 3 windings. So let's take a look at that for a second. You can see here that we have the north face facing the red 3 windings and the south face facing the 4 red windings. Go back and look at this again. The south face is crossing the 4 red windings. At the same time, the north face is crossing the 3 yellow windings, which is on the other half of the stator. So the stator is 360 degrees around it. So the first half of the stator is generating the red sine wave, and at the same instantaneous time, the yellow half of the same stator, the other half of it, is also generating this yellow sine wave. And since the two are in series, then their composite sum generates this dotted black line sine wave. It's all described here if you want to stop and read it for a few seconds. I've also made some changes to this drawing here because I've learned more about this drawing. The blue 120 volt phase, this is a physical view. This is how the wires are physically wired. So if we start with the common side, the black 3, if you don't remember what that is, the common side, black 3, 60 hertz right here, comes in on slot 21. So we'll go back and look at this thing again. Common side, slot 21, it goes through and out on winding G, comes over, comes down, goes through this winding, around this winding, around this winding, around this winding, around this winding, all the way over to this other winding, around this 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 winding, and down to blue 3. So those slotted coils are all in series, even though this half is wired reverse of this half. They're all in series. And the reason this is winding, notice this one's going this way and the other one's going the other way. That's because we have opposite faces of the rotor cutting those. Right now we have 0 current coming out of anything because these windings aren't being cut by the rotor face. These aren't being cut. These are being cut equally so they cancel, and nothing's in here to be cut. Over here at the same time in the south face, it's the south face. It's cutting these 2, which cancel, and these 2, which cancel. These 4 have nothing in them, and these 2 aren't being cut. So we have 0 current out of the generator phase at this time. The bottom view down here, I've left out the way I used to look at it, and that was a virtual view. I thought the coils, were just coils within coils, but they're really connected in series like shown up here. So I left this for reference. This is not correct down here. This is correct up here. This is physically correct. And this is what's going to be used when we actually wind the windings. Wind the coil windings. So I just want to relate these few changes to this drawing with the other drawings. We're currently looking at the red windings, red power windings. If we turn those off, you notice first of all that the missing windings on the top, on the red phase. Turn that off and turn on the blue phase. Missing windings on the bottom. And that's what it shows you over here in this other drawing. Blue phase has a missing winding here. The red phase has a missing winding over here. So everything's still copacetic. I just want to make sure that you understood this is what the actual sine wave would really look like. And hopefully this will clear the air for you also. Two other issues have been addressed in this particular drawing. Notice it's updated today. I made the coils the right color. So the red coil phase, all the coils are red. Blue coil phase, all the coils are blue. Another change I made has to do with the number of turns on the coils. These circles here with the number, that's 18 turns. That's what was really on, how many turns were on slots 10 to 15 inside that slot. And that's the fourth winding. I've gotten rid of the fourth winding completely. I'm just using 7 windings in each phase. So I'm going to estimate half those turns are for 60 volts, 60 hertz, I should say. So we're just going to use number 9. So what I did, I changed the red coil turns was increased to compensate for the 9 turns lost on the coil removed from slots 15 to 10 up here. So I pick up 9. So this one was 18, 19, 20, 21, 22. I picked up 4 there. This one was 19, 20, 21, 22. Picked up 3 there. This picks up 19, 20, 21. That's 2 more. I make 7 plus 2 is 9. So I picked up, I'm making this 21 turns. So now I got 21 turns, 22 turns, 22 turns, 22 turns, 22 turns, 22 turns, 22 turns. And the same on the blue, I just didn't change it yet on the blue. I want you to see how I got to the 9 turns being added to all of these coils. So I should end up the same 120 volts AC at 60 hertz. So I just want to clarify that. And I think now we're ready to move on to the physical aspect of wiring these coils.